Hello guys, today we'll talk about Floyd-Warshall algorithm. So here we have the weight graph and 1, 2, 3, 4 are the vertices of the graph and this 9, 6, 5, 2, minus 4 and 1 are the edge weights. So basically what we have to do is we have to find shortest distance to each vertex. For example, we took the vertex 1, we have to find distance between 1 and 2, 1 and 3 and 1 and 4. So there are some other algorithms like the Dijkstra algorithm. It's not like in only one execution we will find out the shortest distance between every path or vertices of this graph. So rather than applying 4 times the Dijkstra algorithm, one another solution is there, that is Floyd-Warshall algorithm. So let's talk something about Floyd-Warshall algorithm. No, now it follows dynamic path. It follows dynamic programming approach. Dynamic programming approach. So simplifying a complicated problem by breaking it down into simple sub-problems in recursive manner. Basically what Floyd-Warshall algorithm do, it simplifies the program into subparts in recursive manner. So we can say in dynamic programming, some sequence of decision needs to be taken out at each step and finally we'll get the result. Decision at each step should be taken. So one main problem I would just want to discuss is in Dijkstra algorithm we can't take negative edge weights, but in Floyd-Warshall algorithm it works with negative edge weights, like here it is -4. Now let's talk about the working principle of Floyd-Warshall algorithm. So basically we have to find the shortest path from one vertex to another. Now it's not like shortest path would be from 1 to 2 or 2 to 4. It can be from 1 to 3 and then 2 and 1 to 4 and then 2. So what we have to do is we have to take one middle vertex at every step and find the distance between all the vertices, taking that as a middle vertex. So how we have to approach it? First we have to draw a single matrix, like we have to draw a distance matrix, and then we have to solve it, and again next step is we have to take 2 as the middle vertex and then 3 as the middle vertex and then 4 as the middle vertex. So by this we can by this steps we can find which can be the shortest path. Now let us move towards the following steps we have to do to solve the problem. Here we made some of the matrices, distance matrices, and D0 is basically the matrix. I'll just show you how I made it. And first we have to take the diagonals 0, as we don't have 1 to 1 vertex distance. If we consider this diagram, we won't have 1 to 1. Similarly 2 to 2, like 2 to 2 vertex distance is 0. So we have to take it 0. And now how we have to calculate is this edge weights are from 1 to 2 is 9. So from 1 to 2 the edge weight is 9. So by this, like I'll just show from 1 to 3. From 1 to 3 it's -4, and from 1 to 4 we have to see that this path is directive, so we have to consider direction in it. So now from 1 to 4 there is no path shown in this diagram, so we have to take it infinity. Now by filling this, Similarly, we have to find D1 in consider of first vertex, D2, D3 and D4. So after making this distance matrices, we came up with an equation that how we find the minimum distance among these matrices. So this is the basically the formula of Floyd-Warshall algorithm, how we have to find the minimum distance between two vertices. Let me show you. For example, we took k as 4, 1 I as 1 and j as 2. Now we have to just apply it, and by applying it to this equation, by uh, putting the values, we'll just get the like k4 and ij as 1 and 2 will just get 9. So let us see over here that 1 and 2 we get 9. So basically this is how we can find the shortest path between all the uh, edges and all the vertices. So this is all about the working of Floyd-Warshall algorithm. Hope you will understand how this all works. Thank you.